Hi there, in this video I'm going to talk about the phase of a complex number. So if I ask you what's the phase of, let's say, 1 plus I, what will you say? Well, we can easily plot this in our graph, and we're going to use the Gaussian plane, in which we don't have x and y axis anymore, but we have the real axis and the imaginary axis. So we can say, okay, fair enough. We do have 1 plus I, so this value here will be 1, and this one will be 1i, and we are basically looking at the vector here like this, and we want to find the angle. Now, theta. Now, the thing is that for a complex number, the phase is given by the arc tangent of an imaginary number over the real part. So, in this case, theta will be the arc tangent of, well, 1 over 1. So basically, theta will be the arc tangent of 1. So theta is just 45 degree. So the angle we found is just 45 degree. Now let's go on with this. Let's suppose we want to find the phase of, I don't know, 10. Like, what if we have just a real number? Well, if we have just a real number and I ask you what's the phase of, let's say, 10, what will you say? Well, it's pretty straightforward, really. Many of you already, I'm pretty sure that you already talk about this kind of thing, but anyway, it's just really easy. So let's suppose that we have 10 here and we have no imaginary number, because any real number can be expressed as an imaginary number, but with basically complex number, but with a real part and a zero imaginary part. So any real number can be expressed as a complex number, really. But since we have no imaginary part, this angle here, which is theta, will be just 0 degree. Therefore, if we apply the rule that we just talked about earlier, so that the phase is the arc tangent of the imaginary part over the real part, well, we will just have that that theta will be the arc tangent of 0 over 10, so the arc tangent of 0, which is essentially 0. So the phase is just 0. But I know that you already grasp the concept, but I want to make one more example, and this is actually going to be useful because, you know, you're actually thinking about, yeah, okay, I got it. If I have a real number, the phase is always going to be 0, right? Yes, but it is not exactly correct. And I'm going to tell you why in just a little bit. Well, just a little bit, let's say now. So with the concept of before, and this is going to be the tricky part, what if I ask you what's the phase of negative 1000? I know what you're thinking. You're thinking, okay, all right, I just did the same thing as before. So this is basically going to be my real axis and the imaginary axis, and we're basically going to be, you know, somewhere here, like let's say -1000. And therefore we're going to have something that it's an angle theta, so it's still going to be 0, right? No, it's not going to be 0. The reason for that is that when we're dealing with these kind of things, we're dealing with the phase, when we have a negative real number without an imaginary part, we're we're not going to be on this side, we're going to be on the opposite side. So it's like thinking about going the other way, and there's something called, well, I'm not going to talk about Riemann surfaces and so on, but the key idea is that you're basically cutting it and passing it over. So whenever you face an a negative real number, and they ask you a phase, it's going to be on the opposite side, and it's going to be negative 180 degrees. So in this case, we can say that theta is on the opposite side because it's negative. So it's negative 180 degrees. So this is why I wanted to make this example. And I'm going to make one last example. And in this case, I'm going to ask you, well, we have been talking about complex numbers with real part and imaginary part. We have been talking about positive and negative real number without an imaginary part. What if I give you an imaginary number? Well, a complex number with an imaginary part, but without a real part. So what if I ask you what's the phase of J? Well, J basically means I. If you're The reason why I use J, I don't really like to use J. I generally use I. But in many texts you're going to find J, which stands for I. It really depends on what you're studying. If you're studying mathematics, and you're basically going to be fine, you're going to find I everywhere. But if you're studying engineering, well, then it's going to be slightly different, because you may have exam about electrical engineering and or like system analysis and so on. So you know, like even when you will deal with signals and so on. So you may find J we stand for I, because they're trying not to confuse it with current, which is still I, and so on. I don't like that approach, because I generally use the capital I for current, so there's no confusion in between. But anyway, that's the standard. So anyway, let's crack on. What if I ask you what's the phase of an imaginary number? Just an imaginary, a complex number with just the imaginary part and without the real part. Well, let's draw our Gaussian plane. So we're gonna have the real number and the imaginary number here on the other axis, but in this case, we're just gonna have J or I, call it whatever you want. We're basically going to be interested in this, okay? And this angle here, since we only have an imaginary number, it's going to be 90 degrees, because we can say, okay, I or J is located on the imaginary axis. So theta is 90 degrees, which is also one of the reasons why whenever you have imaginary number and you use them in linear algebra, you can do like a 90-degree rotation and so on. But I'm not gonna talk about it. I already talked about it in other videos, so this is just gonna be like quick recap for the like an integration video. Okay, so that pretty much it. If you want another one, feel free to ask. It's fine. But I think this is pretty much it.